Every day, millions of people descend into London's underground without realizing they are traveling through one of the largest archaeological excavations in modern history. Beneath the stations, beneath the tunnels, beneath the constant rumble of trains, there are forgotten cemeteries, lost rivers, Roman roads, medieval foundations, ancient plague pits, entire pieces of history buried beneath the modern city. And many of them were discovered by accident, not by archaeologists, by machines. In the 19th century, London faced a problem it could no longer ignore. The city was growing faster than its streets could handle. Horse-drawn traffic clogged the roads. Goods moved slowly. Workers spent hours crossing the city. Above ground, London was becoming a victim of its own success. The solution seemed impossible. If there was no room to expand outward, perhaps the city could expand downward. But building a railway beneath one of the oldest continuously inhabited cities in Europe meant digging through nearly 2,000 years of human history. Every shovel of earth contained a story. Every tunnel cut through forgotten layers of the past, and the machines sent underground to solve London's transportation crisis soon found themselves uncovering secrets nobody expected to find: steam-powered excavators, tunnel shields, mechanical drills, compressed air systems, enormous engineering devices designed to conquer geology. Instead, they often found history. Workers digging new tunnels uncovered Roman artifacts, untouched for centuries. Construction crews stumbled upon burial grounds whose existence had long been forgotten. Entire sections of lost London emerged briefly into daylight, before disappearing once again beneath concrete and steel. The public saw stations. The public saw trains. The public saw progress. What they rarely saw was the hidden world being destroyed, uncovered, documented, and buried again beneath the growing underground network. Today, the trains still run. The tunnels still carry millions. But beneath every journey lies a deeper story. Because the machines that built London's underground did more than create a railway. They peeled back the layers of a city and revealed how centuries of human lives had accumulated beneath the streets. The question is not how the underground was built. The question is what those machines found while they were digging, and what had to be sacrificed to build the modern city above the forgotten one. Welcome to History Forged. This channel explores the rise of industry, the evolution of engineering, and the people who worked inside the world's most powerful machines. If that sounds interesting, subscribe and join us for more industrial history and engineering documentaries. Long before the first underground train carried passengers beneath London, the city was facing a crisis created by its own success. By the early 19th century, London had become the largest city on Earth. Its population was expanding at a pace few people had imagined possible. Factories attracted workers from across Britain. Trade flowed through the docks along the Thames. Commerce, government, finance, and industry increasingly concentrated themselves within a single urban organism. The city generated wealth on an unprecedented scale. But every new resident added pressure to a transportation system that had been designed for a much smaller world. The streets were overwhelmed. Horse-drawn wagons competed with carriages. Omnibuses crawled through crowded roads. Pedestrians squeezed through narrow passages packed with traffic. Moving across the city became an exhausting and unpredictable process. A journey of only a few miles could consume hours. For workers, delays meant lost wages. For businesses, delays meant lost money. For government officials, delays threatened the efficiency of an empire whose administration increasingly depended on London. The city could not continue functioning this way. Yet expanding above ground presented its own problems. London was not an empty landscape waiting to be developed. It was already densely built. Homes, warehouses, churches, factories, markets, and offices occupied valuable space. Demolishing large sections of the city to create new transport corridors would have been enormously expensive and politically difficult. Land ownership was fragmented. Property values were rising. Every proposed route faced resistance. The city needed transportation capacity without destroying the city itself. This problem became more urgent with every passing decade. The Industrial Revolution had changed the scale of movement. Railways connected distant regions of Britain. Goods could travel hundreds of miles. Passengers could move between cities faster than ever before. Yet when those passengers arrived in London, they encountered chaos. Mainline railway terminals were often located around the edges of the city. Travelers arriving from different regions still needed a way to reach central destinations. Goods arriving by rail faced similar obstacles. The national transportation network ended precisely where demand became greatest. A gap existed between the railways and the city they served. That gap became one of the most important infrastructure problems of the 19th century. Engineers, politicians, and investors began searching for solutions. Some proposed wider roads. Others suggested elevated railways. But each option created new difficulties. Wider roads required demolitions. Elevated structures would cast shadows across neighborhoods and provoke opposition from property owners. The city appeared trapped. Then attention turned downward. The idea of moving transportation beneath the streets was radical. Cities had tunnels, they had sewers, they had underground storage spaces. But the concept of a large passenger railway operating below one of the world's busiest cities seemed almost impossible. The technical challenges were enormous. How could tunnels be excavated beneath existing buildings? How could engineers prevent collapses? How could smoke from steam locomotives be managed underground? How could thousands of passengers safely travel beneath a city built over centuries? No one possessed complete answers, yet the pressure for a solution continued growing. The transportation problem was not the only challenge. Beneath London's streets existed another obstacle: history itself. Unlike newly developing industrial cities, London sat upon layer after layer of human occupation. Roman Londinium had left foundations, roads, walls, and artifacts. Medieval London had added churches, houses, workshops, and burial grounds. Successive generations built upon the remains of previous generations. Fire, war, reconstruction, and expansion created an urban landscape where centuries accumulated vertically beneath the surface. The city above ground was only part of London. Another London existed below. Much of it had been forgotten. Lost rivers flowed beneath streets. Ancient cemeteries disappeared from memory. Buildings vanished from maps while their foundations remained buried underground. Each generation left traces that became hidden beneath the next. Most people never thought about this invisible city. They walked above it every day, without knowing what lay beneath their feet. But any attempt to build an underground railway would eventually collide with that buried world. The deeper engineers looked, the more complicated the challenge appeared. Geology added another layer of difficulty. London clay offered advantages because it was relatively stable compared to some other soils. Yet stability did not eliminate risk. Water infiltration remained a concern. Unexpected ground conditions could threaten entire projects. Excavating beneath populated neighborhoods meant that mistakes could have catastrophic consequences. A tunnel collapse might damage buildings above. Lives could be lost. Public confidence could evaporate overnight. Investors understood the risks. Governments understood the risks. Engineers understood the risks. But they also understood something else. The city could no longer afford inaction. The old transportation system was reaching its limits. Every year the congestion worsened. Every year demand increased. Every year the pressure for a solution became more intense. The problem had become too important to ignore. London needed a new transportation system, a system capable of moving large numbers of people through a city that had run out of space. A system that could connect railway terminals. A system that could operate beneath one of the most crowded urban environments in the world. And solving that problem would require machines unlike anything London had previously seen. Machines powerful enough to cut through clay, brick, stone, and history itself. Machines that would descend beneath the streets and begin opening a path through a city layered with nearly 2,000 years of human life. But before those machines could uncover London's buried secrets, someone first had to believe such an impossible project could actually be built. The idea of building a railway beneath London sounded absurd to many people. In the middle of the 19th century, railways were symbols of progress, but they were also enormous physical systems. Tracks required land, stations required space, locomotives produced smoke, noise, and vibration. Everything about rail transportation seemed designed for open air. The notion that trains could operate beneath one of the most crowded cities in the world appeared closer to fantasy than engineering. Yet London's transportation crisis was becoming impossible to ignore. By the 1840s and 1850s, the city had reached a scale that older transportation systems could no longer support. Mainline railway companies had successfully connected London to the rest of Britain, but their stations remained separated from one another. Travelers arriving at one terminal often faced long and frustrating journeys to reach another. Merchants encountered the same problem. Workers encountered the same problem. The city itself encountered the same problem. The transportation network had succeeded everywhere except at its center. That contradiction created an opportunity. Among the engineers who recognized it was a man named Charles Pearson. Pearson argued that an underground railway could connect London's major terminals while reducing congestion on the streets above. The proposal attracted skepticism. Many believed construction would be too expensive. Others feared underground travel. Some worried about safety. Others doubted passengers would willingly enter tunnels beneath the city. Yet economic pressure continued pushing the idea forward. Eventually, investors, railway companies, and political authorities agreed to support the project. The result was the creation of what would become the first section of London's underground system. Construction began in the early 1860s, using a method known as cut and cover. The technique was straightforward in theory and disruptive in practice. Workers excavated large trenches through existing streets. Tunnels were built inside those trenches. The trenches were then covered, restoring the road above. The method avoided some of the technical challenges associated with deep tunneling, but it created new problems. Entire streets became construction zones. Traffic was disrupted. Businesses complained. Residents endured noise, dust, and upheaval. Building the future required temporarily dismantling parts of the present. The machinery used during these projects reflected the industrial capabilities of the era. Steam-powered equipment assisted excavation. Mechanical lifting devices moved enormous quantities of earth. Rail systems transported spoil away from construction sites. Thousands of workers operated alongside machines that represented the cutting edge of Victorian engineering. The machines were impressive, but they were entering territory unlike any industrial project before them. Most excavation projects dealt primarily with geology. London's underground builders faced geology and history simultaneously. Every trench exposed something unexpected. Roman foundations emerged from beneath streets. Fragments of ancient walls appeared. Artifacts, lost for centuries, resurfaced. Construction crews frequently encountered evidence of previous generations whose existence had long vanished from public memory. The city was revealing itself, layer by layer. What began as a transportation project increasingly resembled an archaeological expedition. Yet, archaeology was not the goal. The objective remained transportation. Every discovery created delays. Every obstacle threatened schedules and budgets. The workers excavating these routes often had little choice but to document what they found and continue digging. Progress demanded movement. The railway had to advance. When the first underground line opened in 1863, it immediately demonstrated the value of the concept. Passengers embraced it. Traffic moved more efficiently. Connections improved. The impossible idea suddenly appeared practical. Success generated demand for expansion. Additional lines followed. New stations appeared. More sections of London became connected. The underground evolved from a single experiment into an expanding system. But expansion created new challenges. The cut-and-cover method worked in some locations, but it became increasingly difficult as the network grew. The city above remained crowded. Excavating major trenches through developed districts became more disruptive and expensive. Engineers needed a new approach. That solution emerged through advances in tunneling technology. One of the most important innovations was the tunnel shield, pioneered by engineers such as Marc Isambard Brunel, and later refined for large-scale underground construction. The tunnel shield allowed workers to excavate while protecting them from collapse. Instead of opening massive trenches from the surface, engineers could move underground, creating deeper tunnels beneath existing buildings. This changed everything. The underground was no longer limited by the streets above. It could expand into areas previously considered inaccessible. New machines entered the system. Mechanical drills increased excavation speed. Compressed air systems helped manage difficult ground conditions. Improved lifting equipment handled vast quantities of material. The machinery became more sophisticated because the challenges became more sophisticated. Each technological breakthrough enabled further expansion. Each expansion uncovered more of London's hidden past. Lost rivers were encountered beneath the city. Ancient infrastructure reappeared unexpectedly. Burial grounds emerged where no one expected them. Entire forgotten landscapes briefly returned to visibility before disappearing once more beneath concrete and brick. The workers building the underground occupied a strange position in history. They were simultaneously creating the future and uncovering the past. Every tunnel pushed London forward. Every excavation revealed where London had come from. The deeper the system expanded, the more apparent this contradiction became. The underground was not simply a transportation network. It was a machine for peeling back layers of time. By the late 19th and early 20th centuries, the network had become one of the most ambitious urban infrastructure systems in the world. Millions depended on it. Businesses depended on it. The city depended on it. The underground solved the transportation problem that had once threatened to overwhelm London. But success carried consequences. Because the deeper engineers dug, the more secrets they encountered. And the machines that made expansion possible were now operating in an environment where every new tunnel risked disturbing something that had remained hidden for centuries. The transportation system was growing larger. The discoveries were becoming stranger, and the workers closest to the machines were about to find themselves standing at the intersection of engineering, archaeology, and danger. To understand how London's underground was built, it is necessary to imagine the city not as streets and buildings but as layers. Layers of clay, layers of brick, layers of forgotten construction, layers of human history compressed into the ground beneath millions of people. The machines sent underground were designed to solve an engineering problem, yet every foot of progress required them to cut through centuries of accumulated civilization. The earliest sections of the underground relied heavily on cut-and-cover construction. From above, the process appeared brutal. Entire streets were opened. Buildings were sometimes demolished. Workers excavated vast trenches through the heart of the city. Steam-powered cranes lifted earth from the excavation. Rail carts carried spoil away. Temporary bridges allowed pedestrians and vehicles to cross active construction zones. The city remained alive, while parts of it were being dismantled. For the workers inside the trenches, the environment was dangerous and constantly changing. Walls of exposed earth surrounded them. Utility lines had to be relocated. Groundwater threatened excavations. Every day required careful coordination between men, machines, and engineers. The machinery itself was relatively simple compared with later systems. Steam engines powered hoists. Mechanical winches moved heavy materials. Cranes swung loads overhead. Iron rails guided carts filled with excavated soil. The rhythm of construction was repetitive but relentless. Dig, lift, move, reinforce, repeat. As the underground expanded deeper beneath London, however, the machinery evolved dramatically. Surface excavation could no longer solve every problem. The city above was too crowded. Property values were too high. Disruption became politically unacceptable. The future of the underground would be built far below the streets. This required a different type of machine. The tunnel shield became one of the most important engineering innovations in the project's history. At first glance, it appeared surprisingly simple. A large iron structure positioned at the front of the excavation. Workers operated within protected compartments while removing soil ahead of them. As material was cleared, the shield advanced. Permanent tunnel linings were installed behind it. Then the process repeated, slowly, methodically, relentlessly. The machine did not attack the earth with speed. It advanced with patience. Every movement was measured in inches rather than yards. Yet over months and years, those inches became miles. The tunnel shield changed the relationship between workers and the underground environment. Before its adoption, collapses represented a constant threat. Now workers had a protective structure, separating them from the surrounding ground. The danger did not disappear. It changed form. The underground environment created challenges that surface construction never faced. Air became a problem. Visibility became a problem. Water became a problem. Pressure became a problem. The deeper engineers traveled beneath London, the more complex the system became. Compressed air technology emerged as another critical tool. In areas where groundwater threatened excavations, pressurized work environments helped prevent flooding. Workers entered chambers where air pressure exceeded normal atmospheric conditions. The system protected tunnels from water intrusion, but it introduced new physical risks. The machine could manage geology. The human body had to manage pressure. Mechanical drills eventually supplemented traditional excavation methods. Their rotating heads attacked clay, gravel, and mixed ground conditions. The sound echoed through confined tunnels. Metal struck earth. Vibrations traveled through surrounding structures. Dust filled the air. The underground became an industrial environment, hidden beneath an ordinary city. Above ground, people attended markets, visited shops, worked in offices, walked through parks. Below them, enormous mechanical systems carved pathways through the earth. Most Londoners never saw this hidden world. The workers lived inside it. The underground construction environment had its own atmosphere. Steam condensed on cold surfaces, lantern light reflected from wet walls, mud covered boots and equipment. The smell of damp clay mixed with coal smoke and machine oil. Every surface seemed coated in moisture or dust. Noise never completely disappeared. Pumps operated continuously. Machinery vibrated through tunnel walls. Metal components struck one another with rhythmic regularity. The deeper construction advanced, the more isolated workers became from the city above. Yet the city constantly announced its presence. Excavations frequently encountered unexpected obstacles. A machine digging through clay might suddenly strike masonry. Workers investigating the obstruction could discover forgotten foundations. A tunnel boring through one section of the city might reveal remnants of Roman occupation. Another might expose medieval infrastructure. Another could uncover burial grounds lost from public memory for generations. These discoveries interrupted the normal rhythm of construction. Engineers evaluated the obstacle. Surveyors documented the location. Authorities determined how to proceed. The machine waited. Then the work resumed. This cycle repeated throughout the history of underground construction. The machinery was designed to create transportation routes. Instead, it often became an accidental archaeological instrument. Every excavation exposed evidence of previous Londoners. Every tunnel became a narrow window into another century. The machines were not searching for history. History simply happened to be in the way. This created one of the underground's most remarkable contradictions. The system represented modernity, industrial progress, engineering innovation, yet it could only move forward by passing through the physical remains of the past. The deeper engineers went, the more obvious this relationship became. London was not one city. It was many cities, stacked on top of one another. Roman London, medieval London, Georgian London, Victorian London, all occupying the same physical space. The machines building the underground moved through them all. But the greatest challenge was not archaeology. It was maintaining control. The underground environment remained unpredictable. Ground conditions changed unexpectedly. Water appeared where none was expected. Structures shifted. Mechanical failures occurred. A mistake on the surface could be inconvenient. A mistake underground could be catastrophic. The workers understood this. Every machine operating beneath London carried enormous responsibility. The tunnel had to remain stable. The city above had to remain standing. And every day, thousands of tons of earth rested only feet away from the men responsible for keeping disaster from occurring. The machinery made the underground possible. But the machines alone were never enough, because beneath the steel, steam, and engineering calculations stood workers willing to enter spaces where collapse, flooding, and hidden dangers were constant companions. And it was those workers who ultimately paid the price for pushing London's railway deeper into the earth.